new lesson of ours, lesson 5.3, when we're solving by addition, also known as elimination. That's another name that math books, math teachers will use when they're talking about solving systems by addition. They might say it's solved by elimination instead. So when both equations are in standard form, you remember this from last year's standard form, ax plus by equals c. Remember that from last year? Ax plus by equals c. So when it's in standard form, the x's and y's are on the same side and the constant's over on the right by itself. So when both of them, notice both of them are in that form, ax plus by equals c. If both of their if their a values are opposites, a is what the x is being multiplied by. So if their a values are opposites, or, and this is, put a circle around that, even though I boxed it, circle it, or, doesn't have to be both of them. Or their b values are opposites. So the y's are being multiplied by something, that's called the b value. So if a values are opposites, or their b values are opposites, doesn't have to be both. Hear me on that right away. I don't want you to, say, I can't do this because they're not both opposites. If either of them are, then we can just add the equations together. It's going to be go right to work. I'm not going to have to do any renaming. So let's look at this system of equations here. 3x plus 2y equals 7. What's the a value in that one? 3. Everybody, I want everybody participating. No hands need to go up. What's the a value in that first equation? 3. What's the b value?
2.
What's the c value?
7.
Okay. How about the second equation? Negative 3x plus 4y equals 5. What's the a value?
Negative 3.
Negative 3. What's the b value?
4.
4. And what's the c value?
5.
5. Okay, so which of those are opposites? The a's or the b's? The a values are opposites, aren't they? The a values are opposites. One of them is 3, the other one is negative 3. So that's what we need to zero in on. We need to say, are the a values opposites of each other, or are the b values opposite of each other? If one or the other is, we need to just go to work adding them together. Because what happens when you add opposites?
You
get 0. And if you have a 0x, that's really the same as. No, 0x is not the same as x. It's the same as 0. 0 times something is 0. And when you add 0 to those y's, what are you going to get? Those y's. No. Okay. Adding opposites is going to create 0. So that means we're going to have 0 x's. If we have 0 x's, that means we really have 0. If we add 0 to something, does it change its value? No, this is not stuff we should be stuck on right now. What's going on here? Okay, so let's go to work then. They're already written here for. Well, maybe I wanted to do this. Yeah, I want us to write them down. Okay, so let's write down. You've decided, you know what? They're addable. They have opposite a values. So this would be the place if we had any subtraction as we're rewriting them, we would change it to add the opposite. Do we have any subtraction to deal with? No. Okay. So we're going to put in an addition bar, just like we would if we were adding some numbers together. Good old-fashioned way without a calculator. Put a plus sign over here showing that you're going to add. But this is not like adding a triple-digit number or a double-digit number. You don't have to start on the right and work your way to the left. You can go either direction. So you can start on the left and work your way across, or you can start on the right and work your way that way. It doesn't matter. Here's what's going to happen. We're going to add these columns together. So this 3x is going to be added to this negative 3x. What's going to happen? Okay, let's just do this. You know what? I think let's just be lazy. They're going to cancel each other out, aren't they? Okay. So now what do we have? 2y plus 4y. 6y. 7 plus 5. 12. So the same thing would have happened even if we would have started on the right and moved backwards. 7 plus 5, 12. bring our equal sign down, 2y plus 4y, 6y. And then we see, oh, you know what, those x's are going to cancel each other out. Well, what do we have to do now? Guess what, what are we solving for right now? Y. So we're going to go ahead and solve for y. What are we going to do to both sides? Divide by 6. 12 divided by 6. 6y divided by 6. What does y equal?
2.
Y equals 2. Okay? So are we done?
Now we put y back in for one of the equations to find out.
Now we gotta solve for
X.
x, don't we? Yeah, now we gotta solve for x. You got a whole bunch of white space left, don't you?
Yeah.
Oh, good. I'm glad to hear that. Okay. Now, what do you suppose, though? How are we gonna? What are we gonna do to decide to solve for x? One of the equations is not gonna have x alone today, like we've been used to. So, what do you want to do, right?
But y equals 2 for the y and 3x plus 2y equals 7.
Hear me on this, it does not matter which of the two equations you use. But if you're, good at math consumer, you can say to yourself, why would I put negatives when I don't have to? And why would I put bigger numbers when I don't have to, right? So look at the first equation. Are there any negatives involved in it? No? Kind of a little bit smaller numbers involved in it, somewhat. So yeah, let's use the first one. 3x plus 2y equals 7. We're going to substitute into this one what we now know. We now know that y equals 2. The only difference is, you know what, we got to work a little harder than we've had to on this second step than we've had to before in the substitution one. Okay, so we have 3x plus what? 4 equals 7. Okay, you go ahead and finish solving that for x. Anybody else can answer this one?
Yep.
So our final answer is
X from 1
ordered pair 1, 2. Our final answer is ordered pair 1, 2. There's our solution. Okay. Anybody want to go back to any part of that and say what's going on here? Or you ready to roll on? And let's roll on, I guess. Okay. You know what it looks like I want to do here? I have some arrows there. I'm thinking I want to rename those equations. I must want to go, what is the A value in the first one?
1.
1. What is the B value in the first one?
1.
1. And the C value is
8.
8. Okay. What is the A value in the second one? 1. Let's change that to add the opposite. What is the B value in the second one?
-1,
Negative 1. And what is the C value?
-18.
Negative 18. Okay, there's our system of equations renamed so we can look at it and say, do I have either opposite A values or opposite B values? Because all I need is one of them to be opposites. So which ones are?
Means
The B's are, aren't they? So we say to ourselves, okay, good. We can add this together now then. Here we go. Let's add them together because we get opposite B values. In other words, the B's are going, the BY's are going to cancel, aren't they? Okay, go ahead and solve that for Y then. Or X, I mean. How much solve for X? Because that's the remaining variable. When you're done, you can see if you agree with me, or if you gotta straighten me out. You gotta fix mine. You might need to challenge my answer. Remember, I can make mistakes. I know how. And I'm good at it. Okay, so we're going to go with x equals -5. Ready to roll on? Okay. Which equation do you think we should use to solve for y? Isaac likes the top one. What do you want, Cameron? You like the top one too? How many do you think the x plus y equals 8 looks like a kind of a friendly one to work with? I agree. I so agree. Let's go ahead and use that one then to solve for our y. X plus y equals 8. Now you can go back to what it was. You know, we don't have to have those ones in there necessarily. -5 is going to go in for x, and we're going to solve it for y. So go ahead and solve that one for y. I got 13. Do I need to be challenged? So our final answer is -5, 13. I'm going to come over here. I've run out of room. There's my solution. Okay, I have a quick question for you. Could this system of equations be solved any other way, or is this the only way? There are different ways, Braden says. So what other way could we solve it then? You mean with substitute? I'm talking about other ways other than using this addition method. Have we learned any other ways, first of all?
The ways we did.
Ways we did before. Like, what was the one we just quizzed on? What was that method called? Substitution. Could we solve this by substitution? Sure we could. We could get one of those equations rearranged and get the x or the y alone and then do our circle the expression, substitute it into the other one. We could do that. What answer would we get? Maybe let me put it like this. What answer should we get? Same one. What's another way we could solve this? Oh, let's go back one more quiz. Solve by graphing. What's this mulling it? Solve by graphing and find where the lines do what? Meet. Where they intersect. Where would they intersect? Where would these two lines intersect? At -5, 13. So this is just a new method. We now know 3 methods to solve a system of equations. Graphing, substitution, adding them together if their A or B values are opposites. Which one do you think would be the easiest for this one? This one. I think this one. We don't have to rearrange the equations at all, did we? Did we have to get the x or the y alone to graph or to substitute? So this is a pretty good way for a problem when they're both in standard form. Okay? So how are you feeling about, oh, first it looks like I want you to rename getting rid of subtraction. So 4x what?
Plus -2y.
Plus -2y equals 2. And 3x plus 2y equals 12. That one doesn't have a subtraction. Okay? What's going to eliminate this time because they're opposites? The b's are opposites, so then what's going to eliminate? The y's are going to eliminate, aren't they? So we're ready to add this together. We got to make that decision though first, okay? Well, we do have the opposites, so we're ready to add them together. Cancel our y's because that's where our opposites are, and go from there. go ahead and solve for y now. Go ahead, you pick the one you want to do, your choice. You might want to decide, if you want to check to see if you got the same x value that I got before you move on, you can, but then go ahead and move on. Like you know it so well already, you can do it. Marky, is yours done? Okay, come on up here and do it for us on the board. Bring your paper up. And we gotta be able to, come on. You can do it. You got this. And you can use this white space right over here to the left, okay? If you want to bring your paper along so you know in case you get stuck or something. Are you feeling pretty confident about your answer?
Yes, sir.
Okay. You can just write with your finger, it'll let you do that, or you can use a pen if you'd rather. All Sharpie learning on this common that he used the first one. Anybody else use the first one in here? Okay, so should we all be the same y value no matter which equation we use? Right? Okay. So what if you use the second one? Is that okay? So Isaac's saying he chose the second one because then he doesn't have to deal with any negatives. Anybody else have that same thought process? I'm going to use the second one because I don't have to deal with any negatives. Okay? Yeah. So you get to be the decider, right? Thank you, Shmarky. So Shmarky says that y equals 3. All in favor of Shmarky for president? Go, guy. You got it. Okay. So the final answer is
Or 2, 3.
ordered pair 2, 3. Okay, good job. Okay, do we have this? Are you ready to go? Okay, get your loose leaf paper out. Put your heading down. You have